Hi, welcome guys. So today in this tutorial I will going to demonstrate AWS IoT core, and we will send the sensor data from ESP8266 to AWS IoT core platform. For this project I am going to use DHT11 temperature humidity sensor and the LEDs. And we can see that we have the hardware setup with us, for which the red LED is in on state and green is in off state. And this is the thing TED, and we can go here and interact with this device. And let me go to activity tab and turn on the MQTT test client. For this the device is basically publishing data. Let me turn this on. So device is publishing data to this topic TED/telemetry. So we need to subscribe that. Already there are a few subscriptions you can see here. You don't need to bother about these, since we need to first understand what is these things I do thing. So we will then understand this, but let's subscribe this TED/telemetry, which we have defined already in the policy. And okay, so we are getting the data. This is the data which we are getting here. And sending data from AWS IoT core to this NodeMCU setup, we need to publish data on a topic. So right now you can understand that we are publishing data to a topic $AWS Thing TED shadow update. So this is a long topic you can see, but we are here utilizing the feature, the state feature of AWS IoT. So what we are doing is we are making use of state feature. Well, for now the state you can see is red is on state and green in 0 state. So right now I am sending red in 1 and green in 1 on the desired key. So publishing this message will make the green LED, this one, also turned on. So after that what we can see is in the TED shadow accepted part, we can see that we have a message here, and which says state desired red, green and reported. So we are publishing data to this much data only, to that update topic. To this update topic we are just publishing desired data, and this reported data is already updated to the same value. So let me try this once again. So let me turn the red one off. On, it is currently on, we need to off it. So making it publish here. Okay, so in real time the hardware is changed, and desired became 0, also reported became 0, and delta is the change. So we'll discuss this thing in more detail in the tutorial part, but for now you can see that desired and reported are after changing desired, we are also getting change in the reported. So this change we are not doing it, we are not changing it, but it is getting changed, and this is due to this Arduino sketch. So this device is making that change for us. So we will see explain that in the other part. So talking about the requirements for this project, we have this node MCU needed in this project, or ESP32 will be fine. DHT11 sensor, so since we are sending data, any other analog sensor will be fine also, but since I am covering DHT11, you need to have this for showing the data. For showing the data which is coming from AWS IoT, we are using LEDs. Although we can use any other thing, any other output device here also, like relay or anything else. And you need to also have an active AWS account with you. So these are the requirements. Well, circuit diagram is very simple. Here you can see, let me zoom it. Now you can easily see that we have the D0 pin, which is not connected to anything but D1 and D2. So D1 is connected to this digital DHT11 temperature and humidity sensor, and we are taking power, since this DHT11 takes 5 volt, and some node MCUs can give 5 volt and someone can't, but for in my case, if I power my node MCU using the USB cable, I can easily get V in 5 volt. So taking 5 volt to the plus 5 volt of this DHT11 and minus to ground, you can see in the line, and the LEDs are connected to 220 ohm resistors, and the positive ends, the anode end of both the LEDs are, for red LED it is connected to D2 and for green it is connected to D3 respectively. So this is the circuit diagram for this project. Okay, let me zoom out. Okay, so the architecture. Okay, so this is a high level architecture, it is not very deep. It is a high level architecture. You can understand here that publishing data publish is from DHT11 side. We are publishing data on a topic. Which topic? Thing name / telemetry, and this thing name is dynamic, since we are creating our thing with name. Well, I will create a new thing for you guys. For now we can see the thing name / telemetry. We are publishing data every 10 seconds, so temperature and humidity data, and AWS test client or any other client after subscribing data, for here you can use anything. So if you are creating a solution or a survey, a thing where you have to take the data as a device data to an app or a dashboard, you can use service AWS services there to connect to that thing. Firstly, to connect to that broker, first thing is connection to the broker, and then you are subscribing to this topic for getting this data. And other thing is sending data from this test client. So we are sending data on this update topic, as you have already shown in the demo, that we are sending data on this topic, update topic, and update topic we are sending data, and we have update delta topic, where the from the difference we are subscribing and getting those data reflected to our device. You are at the AWS management console. Here you can see search for AWS IoT, and AWS IoT core is there. Open it, and here in the manage tab we have things. Now click on create thing, create a simple thing. Next, but let's put only thing name, let's name it Zen. Move to device shadow. So device shadow, earlier device shadow is only classic, now we have also the named shadow. So the topic structure, so what is device shadow is basically, device shadow is the reserved MQTT topics by AWS IoT core, and this will give us option to get, update, delete the state information for a device using the topics, using these topics. So the very important topic here to notice is update topic. Okay, and to get up to update the device information, we need update topic. So what device information we want to update? So let's use the classic topic here. So for classic, the structure is right here. So we are going to save device state of red and green LED. So red and green 0. So reported and desired, we will understand this thing earlier, but now let's assume we will understand this thing later, but now let's assume that reported and desired both are commonly 00 in both in 00 state. So now click on next, and here is very important thing, device certificate. So AWS provides us a TLS based security between the broker and between the brokers and the devices, and the clients we are connecting to AWS are basically the devices we are connecting to the broker uses the certificate to connect to the broker. So it needs the private key and the certificates generated using the AWS IoT core to connect to this broker. So not the core architecture, how this work is defined in this repository. It is very helpful. If you can see, so you can see that we have the CA authority. So we can use private CA authority in Amazon, but for this tutorial we are going to use Amazon root CA authority. So the CA authority is the one who guarantees that the client, the certificate carried, just we are signing, it is signing these certificates carried by one client and the second client and the broker. So it signs the certificate. So CA authority signs the certificate, and so broker and client communicate you via TLS. So now let's generate the certificate using the first option only. So we have other options, but now we are using this one only. So next, for creating a policy, click on this create policy button, and now you need to name a policy name. So Zen is the let's name it Zen underscore policy. You can name it anything, it's just a convention I am using. So for statements, we have the actions and resource. For one action, what are the resources we want to give to this action? So for IoT connect, in many tutorials you have seen that they have just in action they have put IoT star, and in resources they are giving anything. So this is the this in the actual real scenario you don't do this. So there is no point of resource ARN and action, and there is no point of ACL, access control. So for limiting the resources of AWS, that if this thing can only access certain topics only. So in my demo you have seen that this TED demo, you have seen that I can access only this topic only. If I want to, okay, publisher, if I want to publish on AA and something, publish it, you can see connection error here. So I can't do publish on any other topics. So that's what we are making statements in the policies. So for connecting, we are giving a resource as star. So anyone can connect, which have the proper credential, which have these certificates and all the things available with them, they can connect only. So we are making it as a star and making allow. Make one more statement, IoT publish. So what topic to publish? So replace this with that topic. So I am the thing name is Zen, so let's make it Zen / telemetry for publishing the temperature humidity data, and comma second topic. So the structure till this is same. So what is the second topic? The second topic is nothing but the device shadow topics. Since we are using the device shadow topics, click on update. Since we are using these device shadow topics, we need to give permission to access it from other clients. Okay, so the device shadow topics we are using in this project are update. For publishing, just I am talking about publish. For publishing we need, okay, let me see this one, this thing. I will explain this, what is this thing which I am opening every time. This is MQTT box, it is also a MQTT client. We can add multiple clients in this MQTT box, and I will add the one client which I am just creating, this new thing which I am creating. I am also going to connect this with MQTT box. So let's see this. This is the publisher. We are publishing the red and green state here, and making changes to the device accordingly. So this is the second topic, $AWS things TED. Also change this TED to our thing name, which is Zen. This is the second one, and the third one is get, shadow get. Why we are using these three topics only from all these listed topics? Why we are only using this, I will explain it later. Okay, So you can see AWS Zen shadow update and shadow get, make it allow, add a statement. So now let's see IoT subscribe. So this will permits only these topics which are I am going to put here to subscribe to this client. After connecting client, this topics only can be subscribed. What do I mean by that is that if I am talking about this client only, if I add a subscriber here, XYZ anything can't be subscribed. You can see connection error, it's only disconnected and unsubscribed again. So that's what. So replace with a topic filter. So for subscription we have topic filter here, but for publish we have topic here. So this structure is same for every resource ARN which we are going to define, but replace with topic filter is change. So Zen/telemetry also we are going to subscribe from other clients like from app or dashboard. So we are going to put here this one. For subscribing from the test client of this AWS IoT broker, we don't need to put this in the source ARN. Everything can be subscribed or published from here. Okay, so this thing is common, first one. Second is update delta. So update delta is second one. Okay, AWS, okay, AWS Thing Zen shadow update / delta. So this is basically use of this one. And at last get accepted. So first I need to copy this topic filter till this point, and then AWS Thing Zen shadow get / accepted, making it allow. And now we can see the advanced mode more clearly. It can see Zen telemetry is used for publishing data, also for subscribing. Zen shadow update used for publishing only. Zen shadow update delta used for subscribing. Zen shadow get for publishing, and get accepted for subscribing. So these three are for publishing, these three for subscribing, everything for connect. And there is one more thing, that after subscribing you will not going to receive the data. So there is one more action in AWS IoT. Let me turn to basic mode and add that one also. You can also add from JSON format from here also, but I prefer this one. So add that statement. There is, you will not going to get the data until you can make this IoT : receive to. Since receive work parallelly, since you receive work with IoT subscribe, so the topics of IoT subscribe, we get the data with every resource ARN, with all the resources. So all the resources, which means that these resources only, since IoT receive is directly connected to IoT subscribe. So make it allow, and that's it. So click on create. Zen policy created. Check here, check this one. Zen policy already updated here. Create thing. Okay, so thing created. We have the device certificate with us. Download it. This is the certificate, and this is the public key, private key. Public key is not needed, although we will download it. Private key is there. And Amazon root CA1 also downloaded. I have already downloaded it, so I don't need to. So click on done now, and Zen is there added. We can see that we have ESP8266 Wi-Fi.h for connecting to the Wi-Fi, and we have PubSub client for using the MQTT with Node MCU. So all the MQTT features, basically publishing and subscribing. So Arduino JSON is another library. This library you will get on GitHub, Arduino_JSON. This is another popular library. Well, this library is the official Arduino libraries, but it is still in beta version. And basically it supports all the functions, all the Java JSON, all the functions similar to JavaScript, like for stringify, like for making the JSON object to string, we have stringify method. For parsing it, we have json.parse. So it is very same to the JavaScript methods. So it's very easy to learn. If you have already learned JavaScript, then these method type of json.type of json dot has own property, these are all JavaScript methods, and now it is provided in this Arduino C++ or the given code. We can say that it is very helpful for the JavaScript coders. That's why I have used this. dst.h is used for reading the temperature and humidity data from dst11, and dst type is mentioned here. dst pin is also there, so that we can make the object of dst class using these two parameters. So red and green are the two pins, which are D2 and D3. I have already shown you the circuit diagram, D2 and D3. Okay, we can make it zoom like this. So D2 is connected here and D3 is also there, also to the green pin. So SSID and password are the Wi-Fi credentials, since we are connected to the AWS Cloud IoT. So it is basically needs the internet. So we are in the global network here. AWS endpoint is the URL. We have already seen that while earlier in the settings, while connecting to the MQTT box. We have already seen we need the endpoint. Also in the Arduino sketch we also need the endpoint. So just copy and paste it here. For certificate we have already downloaded in the downloads. You can see that this is the latest. This one is the certificate. Just open it, copy, and the content, just delete it and paste it. For private PEM key, basically private key, hover over it. Okay, this is the private. Just simply open it, copy this one. Just make sure that you are using the same certificate on which you want to connect, of the thing which you want to connect basically. So delete it and paste it. And CA certificate keys, this you don't need to change actually, although you have this AWS where it is Amazon root ca1.pm, but this is the same content which I have pasted here. I will provide this code in the GitHub, so you don't need to change this capm.crt array. So we are using those three above to use in the client cert, client key, and root cert objects. And after that, Wi-Fi client uses this class, and all these four things are very important. And we have declared a message. Now a pops up client object created using AWS endpoint URL, which we have defined. 8883 is the port number for connection in TLS mode. Okay, so AWS supports also the WebSocket, but we are connecting over the TLS basically. So MQTT message received is the method which will be called when any message is received to any of the topic. So this function will call. We have already defined that function, so you can see this is the function which I am referring to. This whole fun, this from here to here. Okay, and apart from that, we have okay, let me see. Okay, now we have the setup method, which is the starting point of this Arduino code. So CL monitor is opening on this port for debugging purpose, just printing this line, connecting, and Wi-Fi.begin is for starting the Wi-Fi connection, and Wi-Fi.wait for connection result. Okay, and then Wi-Fi connected. So there are two more methods you can see. So these are for defining red and green pins, which we have defined above. D2 and D3 is output, and now we are making the DHT pin as initializing it so that we can use it further. Set current time for making connection to AWS secure broker, since it is a SSL TLS based broker, so we need the current time for making the connection. So this is a very important thing, otherwise certificates are flagged as is expired basically. Okay, so this thing is very important. So although you don't need to match the exact time, if you are getting, like in my case I'm not getting exact time, like I am getting UTC minus 530, not plus 530, minus 530, or just the UTC default time. So according to my country, we are ahead of 5 hours and 30 minutes, but still you are able to connect, since the device, since the certificates expiry is not in minutes or hour, it's like 30 years I guess. So you don't need to worry about the time difference if you are getting any. So in the other than that, we are using these two certificates and the private keys here in the set by setting the RSA cert and trust anchors. So these will be set to the Wi-Fi client only, so for making the connection. And now the loop will execute continuously and pops up client first method called. Let's check that method. So here we are checking if it is not connected, it will try to connect and it will connect to the thing. So in my case the thing name is Zen, ZEN. So update these things here also, these three positions. So these two are the subscriptions we are doing, like we are doing for with MQTT box we are doing. Similarly we are doing subscription to update delta and get accepted, and we are sending a empty message to get. What it does is the same thing it is doing here. After you subscribe to this get accepted, and after then you publish here in the starting of your code, it will give you the desired and reported thing, and then you can simply take out this desired, that what is the changes people want from the dashboard. Desired red, just check red and green. If it is 1, turn the LED to on, and it is off, turn it to 0. So how we are doing is we are simply publishing it, and as soon as we publish it we will get this message on the accepted topic. So where we will get this message? Inside the message received method. So here we are making the topic filtering here, that if the topic we are getting message is this topic, and the message we are getting, we are just using these for loops for converting the message from byte actually to char and then string basically. So we are just concatenating the characters to make it a string. So after that we are using the MQTT underscore JSON library, so making an object and parsing this string. JSON string is basically, so parsing this it, and here we are getting the data out of it. Okay, and now this is the type conversion. These two reported values we are converting it to int, not string. So now what we are doing is we are reported and desired, we are checking if the both are equal or not. And since in the initial phase they are not equal, the 0 0 is earlier it is 0 0, now it became 1 0. Then what we are doing is changing the state of the LEDs accordingly, and now updating the same, making the desired and reported to the same values. Just we are making the reported to this value we are getting in the desired. In the desired we are getting red str, you can see red str we are getting in desired, and green str we are getting in desired. We are updating it in reported object. and publishing it using the update method. That's how. And we are doing this inside this inside this if condition. So this condition will not execute once the state gets updated. So that's how we are utilizing this method, and we are not in any kind of deadlock. So here also we can see if the topic is AWS Delta, which is the topic on which we get the message. This is for first time only, and after next time we are getting messages as soon as we get the message update message from update. We get the message in update Delta, and we are publishing to get a message empty get a message, so that we can invoke this if condition only. We just invoke the message received on this part, and this method only get executed again. So this is what I am writing here to minimize the code. So I can write this whole code again here also, but the thing is I'm not getting same message structure in this. This is the different message structure, and if I okay, I'm not able to subscribe. Okay, let me check TED and try to subscribe from here. TED update Delta. Okay, here it is working fine. I can show you from here. Publish. Okay, so you can see only state data changes is only there in the Delta part. So, and what we need is both the desired and the reported, so that we can check if the changes is occurred or not, and accordingly we will publish the message. So that's the reason why we are utilizing the same get accepted here also. And now publish subscription and this updates, just you need to update this TED with your thing name. Okay, and other than that you don't need to do anything else. Publish sub client.loop will make this MQTT client to connect again and again. If the connection unestablished by some reason, it again make a loop connection and tries to connect to the broker again. So that is how this code is working.